All right, so my name is Zachary Peterson, and this is going to be the full adder subtractor demonstration for Lab 6. So the hardware portion requires a lot of things. It's going to be less than Lab 5, which is going to be a ton of TTL chips using AND gates, exclusive OR gates, and regular OR gates. For this one, this chip right here is going to be the 283 chip, which is going to be the 4-bit full adder component. And then this chip right here is going to be the 86, and that will be the exclusive OR gates. So right here, we got the LED representation. This is going to represent the sum of A0 and B0, sum of A1, B1, sum of A2, B2, and A3, B3. And then this is going to be the carry value at the very end. We got these 8 pole resistors to induce current across these switches right here. First is going to be CN, and then down the line is going to go A0, B0, A1, B1, etc., until it reaches A3, B3, for a total of 9 inputs. These yellow wires right here, including this white wire, will represent the CN switch, which is going to be used over here as well, since we needed a lot in both of these chips. So I needed more space in order to carry all those current across. These 4 blue wires right here are going to represent my A values, so A0, A1, A2 down the line. And then we got this white wire, this black wire, and these 2 green ones that will represent the input values representing B. So I got the battery right here. This is going to be the battery pack, and then I am going to, first we need to make sure everything is switched off. Good. All right, I want to plug this in. So I do believe there is an error either with the switches or bad connection from the wires. The math isn't quite adding up how it's supposed to be simulated. But to show that everything is connected correctly. So, for example, that would be A0 and B0. It should only light up this red, signifying the 0, 1, 0, 0, which would indicate 2. But it's still lighting up this first one. I haven't been able to figure it out. I went over this 3 times. It still doesn't really work. Same thing with C, and this should light up at the end. It doesn't. I'm not too sure why. I think it has a problem with the switches, because if we flip 2 more, this is also including A1, so it would be the addition of 3 and 1 should be 4. This one should be lighting up, but this one's lighting up, which is going to be 8. But this is also CN, so actually it was going to be 2, which is even more wrong. But if I take down all of these as such, and then flip these. So we'll do another example. This one's going to be, so A0, B0, A1, B1 should be 2 plus 2, which is 4, but it does 2 here. Do CN should negate any current, but it goes 8. We'll flip these off. I do some little tweaking of the wires, and this is what I'm talking about. The switches are all closed. There should be no current induced over it. However, I'm still getting a connection for 8-bit representation of 4. So I'm going to disconnect this battery, and I'm going to take this apart. So first I am going to do the LEDs as such. And plug this section down at first. These are going to be all the CN wires right here. These are the ground and VCC for those TTL chips. Same for here. And then we're going to take away these wires here. These are also CN. These are going to be the A1s, A2, A3, and A0 wires. Include this one as well. These are going to be the B. These are going to be the outputs of the exclusive OR gate chip. And then these are going to be the output of the adder, the 4-bit adder. Take this out. That's a 4-bit adder chip. This is going to be the exclusive OR gates. These are going to be the resistors in order to induce a current across these LEDs. They're a little finicky. And then these are all 1 kilo ohm resistors. Lastly, we take the chips out. And that will conclude my video demonstration of Lab 6.